the mode from interpolation formula. So we will be talking about the mode of grouped data here. The mode can be estimated by interpolation. Now, let MO be the mode of the distribution. Let L be the lower boundary of the modal class. Let delta 1 be frequency of the modal class minus frequency of the class immediately before the modal class. Then let delta 2 be frequency of the modal class minus the frequency of the class immediately after the modal class. Then let W be the width of the modal class. So it can be shown that MO, that is mode of the distribution, is equal to L, that is lower boundary of the modal class, plus open bracket change in frequency 1 over change in frequency 1 plus change in frequency 2, then multiply by width. Now let's look at this problem. Example 1. The following table shows the frequency distribution of the masses to the nearest kilogram of 100 men. So mass in kilogram, we have 55 to 59, 60 to 64, 65 to 69, up to 100 to 104. So here we are asked to state the modal class, then we are asked to estimate the mode of the distribution. Now, in order to state the modal class here, let's check the frequency. Since we know that the mode is the what? Highest frequency. The class is what? Highest frequency. So the highest frequency here is what? So we have 23, 25. So 25 is the highest frequency. Now, if you now trace this 25 back to the mass here, so you can see that the class 75 to 79 so has the what? Highest frequency. So, and therefore the modal class is now equal to what? 75 to 79. So this is the solution now. So the modal class is equal to what? 75 to 79. Now that is from the table, from the given table here. Now in order to estimate the mode of the distribution now, so we're going to make use of all of the following: MOL, delta 1, delta 2, as well as width, together with this formula. Now, L, lower class boundary of what? Of modal class. The modal class here is 75 to 79. So lower boundary here is what? Lower boundary is what? It should be 74.5. So to calculate the lower boundary here, we need to subtract 0.5 from 75. So if you subtract 0.5 from 75, you are going to get 74.5. So L is equal to 74.5. Now, delta 1. So this is the frequency of the modal class minus frequency of the class before what? The modal class. So we will say 25 minus 23. That one will give us 2. That is delta 1. Then delta 2, frequency of the modal class minus the frequency immediately afterwards, the modal class. So we are going to say 25 minus 13, which is equal to what? 12. Then what else again? Then class width. So the class width is equal to what? 5. The class width is equal to 5. That is from, so if you count from 75 to 79, or just pick any number, so 55 to 59, 60 to 64. So if you count, you can see that the difference is what? 5. So width is what? 5. So let's now go and apply everything into this into the formula. So L is 74.5, delta 1 25 minus 23, it is equal to 2. So delta 2 is equal to 25 minus 13, which is equal to 12. Then width is equal to what? 5. So M now is equal to L, which is equal to 74.5 plus delta 1 is equal to 2. This is the 2. Then divided by delta 1 plus delta 2, 2 plus 12. So this 2 then plus this 12 is equal to what? 14. Then 5 multiplied by 2 is equal to what? 10. So we are having 74.5 plus 10 over 14. So 10 divided by 14 is equal to 0.714. 0.714 plus 74.5 is equal to 75.2 kilograms. So this one will now serve as what? The mode of the what? Distribution to one decimal place. Now, if this example is clear, so I would like you to practice to do this exercise